Dear all, I would like to welcome you all in the lecture series of Basic Electrical Engineering. In this session, you will be learning most important equations which are belong to Module 1 and Module 2. Before going to the examination, I request everyone to go through these equations. This may be helpful for writing the theory part or some numerical example, etc. So please go through the particular equations and note down accordingly. Let us start discussing that. First one is related to Ohm's law. According to Ohm's law, V is directly proportional to I. Voltage is directly proportional to current. So voltage is equal to a constant, that is called a resistance. Resistance into I. Therefore, resistance can be calculated by using the equation R is equal to voltage divided by current. You can represent the same thing with the help of an Ohm's triangle. Voltage then I into R. That means V is equal to I into R. Or V by I is equal to R, or V by R equal to I. This is very important. So another aspect of resistance, R is equal to rho L divided by A, where rho is known as resistivity or specific resistance. Resistance is directly proportional to length and inversely proportional to area of cross section. This point is also quite important. Another important point is related to how to calculate the power. Power for a DC circuit. Power is equal to voltage times current. Or else you can apply Ohm's law, you can modify the equations like power is equal to V square divided by R, or else you can able to write power is equal to I square into R. This is very important equation. Another thing is equations related to series connection and parallel connections of resistor. If two resistors are connected in series, then the equivalent resistance can be written as sum of individual resistance, R1 plus R2. Likewise, if it is connected in parallel, then the equivalent resistance can be written as R1 R2 by R1 plus R2. Okay, so if I talk about the resistance which are connected in series, the overall resistance will be very much high compared to parallel combination. This is also quite important. You may get different kind of numerical example based on this. Please do practice this. Another thing is you need to understand the voltage division and current division formula. I have already prepared a detailed video on voltage division and current division formula. Please go through that. So please do remember, very important. Another thing is related to Kirchhoff current law. According to Kirchhoff current law, the algebraic sum of current meeting at a junction, that is equal to 0. If I talk about KVL, you can able to write summation of E. That means summation of EMF and the summation of voltage drop in a closed loop, that is equal to 0. You can able to apply the same equation and solve many more problems. Then I would like to discuss about how to calculate energy. Energy is nothing but power multiplied by time. So power into time. What is power? Power means voltage into current. That should be multiplied with the time. So I will be getting energy is equal to VIT. You can able to modify the equation, no issue. And also, what is the commercial unit of electricity? So dash is the commercial unit. That is kilowatt hour, kWh. That is also you have to remember. Then according to Faraday's laws of electromagnetic induction, you can able to write E is equal to minus n d phi by dt, where n is the number of turns and d phi by dt means rate of change of flux. Change of flux with respect to time. Minus n, why minus has come? Because Lenz's rule. You have to apply the principle of Lenz's rule. Lenz's law or Lenz's rule. Okay. Another important thing related to AC circuit, you need to understand what is angular frequency. So angular frequency can be written as omega is equal to 2 pi f. What is the unit of angular frequency? Radian per second. And another important thing is supply frequency, number of cycles per second. Supply frequency can be calculated by using the formula F is equal to 1 divided by T, where T, capital letter T is the time period. Then relation between supply frequency and angular frequency, you can able to write the omega is equal to 2 pi f, where omega is known as angular frequency and small letter f is known as lowercase f or small letter f, that is known as supply frequency. Likewise, you can able to note down. Similarly, what is the instantaneous value of voltage and current in AC circuit? Instantaneous value of voltage can be written as V is equal to Vm sin omega t, where Vm is the peak value. I is equal to Im sin omega t. Im is the peak value. Okay, like that you have to remember. Then average value you can able to calculate by using the formula for a complete cycle. E average is equal to, okay, AC sinusoidal waveform, the average value can be written as 2 Em by pi or 2 Vm by pi, anything is okay. That can be written as 0.637 Em. If I talk about the in terms of current, I average is equal to 2 Im by pi, or you can write 0.637 Im. Please do remember this. Likewise, RMS value. You can able to write the RMS value like ERMS equal to EM by root 2, or you can write 0.707 EM. IRMS equal to 0.707 IM. Likewise, one more important terminology which can be expected in the examination, what is form factor? Ratio of R. You will be getting 1.11, like this you will be getting. Likewise, peak factor you can able to calculate. It is also known as crest factor, ratio of maximum value to the RMS value. If you substitute, then you will get 1.414, or you can write root 2, crest factor or peak factor. Some important equations from module 2 I will be discussing. Voltage across inductor you can able to write VL is equal to L dA by dt, where L is the value of inductance and unit of inductance will be Henry only. And also, in case of inductive circuit, you need to define the relation between voltage and current. So if I take voltage V is equal to Vm sin omega t, definitely current is lagging. How can I represent current is lagging? I is equal to Im sin omega t minus phi. And also, in a particular AC circuit, inductor offer certain resistance that is known as inductive reactance. You can calculate inductive reactance using the formula XL is equal to L omega. Omega can be elaborated as 2 pi f. Therefore, L into 2 pi f is equal to XL. If I mention about capacitive circuit, you need to know the total amount of charge stored in the parallel plate, that is equal to Q is equal to C times V. In case of capacitive circuit, the relation between instantaneous voltage and current are as follows. Voltage, if I take voltage as a reference, V is equal to Vm sin omega t. What about the current? Current leads the voltage at an angle of phi. Therefore, I can write I is equal to Im sin omega t plus phi. This is also very important. You need to compare inductive circuit as well as capacitive circuit. Another important parameters are real power, reactive power and apparent power. Unit of real power is kilowatts. Unit of reactive power is kilovolt, kVAR, kilovolt ampere, VR, kVAR. Then apparent power kilovolt ampere. So bifurcate kilowatts, kilovolt ampere. Then volt ampere reactive. Okay, VAR. kVAR means reactive power. Apparent power means VA. So you have to bifurcate the three type of power. Anyway, the power which can be utilized is only real power. Then real power can be computed using the formula VA cos phi, where reactive power can be written as VA sin phi and apparent power can be written as VI. Okay. Then power factor is another important parameter. Most of the examination you can get the question. Define power factor. It is a ratio of real power to the apparent power. With the help of a simple triangle you can able to represent. The base side you can take real power, height you can able to mention reactive power, hypotenuse should be apparent power. Therefore, cos phi means adjacent side divided by hypotenuse. Therefore, you will get real power to the apparent power. Like that you can able to mention. Or else you can able to draw any of the phasor diagram of RC circuit or RLC circuit, whatever it may be. If you draw the phasor diagram, then you will get the cos phi is equal to R by Z, where Z is the impedance. What is impedance? Impedance is nothing but the sum total of resistance or net resistance offered in an AC circuit. Suppose you know R and X. X means reactance. Then you can able to compute by using the formula Z is equal to square root of R square plus X square. This also can be written as in a triangle. The base side you can take R, the height you can able to take it as X, hypotenuse should be Z. In case of RC circuit, it becomes Z is equal to square root of R square plus Xc square, where X is known as capacitive reactance. So Xc can be written as 1 by C omega, where omega can be replaced with a 2 pi f. In case of RLC series circuit, I can able to write Z is equal to square root of R square plus XL minus XC the whole square. Okay, if XC greater than XL, I can able to write Z is equal to square root of R square plus XC minus XL the whole square. So power consumed in an RC circuit can be written as P is equal to VI cos phi. In case of three-phase circuit, you need to know the star and delta connection. In star connection, we can able to write VL is equal to root 3 V phase, where IL is equal to I phase. In case of delta connection, the line voltage and phase voltage will be equal, but the line current is equal to root 3 times phase current. This is very important. So three-phase power you can calculate by using the equation P is equal to root 3 VL IL cos phi. It is in terms of line voltage. But if you want to write in phase voltage, you can able to write 3 V phase I phase cos phi. So 2 wattmeter is more than sufficient to calculate the three-phase power consumed in a three-phase load. So P is equal to W1 plus W2, and also you can able to calculate the power factor by using the equation cos phi is equal to cos tan inverse of W2 minus W1